Okay, top of the hour. Let's start. Hi, everyone. Thanks for coming today for this very dense presentation about Playwright in an hour. So this is not about Shakespeare today. This is about what he's holding in his hand. And that's Playwright the tool. What we're going to try to do is not to make the most of the features, because there's a whole course that I give a whole day about this. What I do want to go through are the main features, but also how it impacts testing, because this is what we do. Playwright is a tool. We use it to do something and not just automation. And I want to see different perspectives, how it affects our work. And we'll try to look at it in different perspectives, like the feedback. How much feedback can we get? Quick feedback, slow feedback. We'll talk about isolation, which is one of the things that Playwright brings with itself. And isolation derives fragility, stability, all the things in between. We'll talk about readability, tests written with Playwright, how they look and what does it mean in terms of readability. And we'll talk about maintenance, how much the test that we have is going to serve me in the next rounds of development, and how much work will go into that, because things are going to change. We'll see how the tests that are created with Playwright change over time. I'm Gil. Welcome to this webinar. I do a lot of webinars, one each month, and I do other videos as well. You can check on my YouTube channel and talk about testing and development, all kinds of things that are related to quality and making software better. I'm a consultant and a trainer. And like I said, what we're going to talk about today is like just a bite out of a big workshop, a bigger workshop, whole day just on Playwright for people who don't know anything about Playwright and web automation. I want to say that today is, if you have some experience with Selenium or Cypress or other frameworks, I'm going to mention them by name very quickly, specifically in the history lesson part about Selenium. But you don't really have to do this. I'm explaining what Playwright does and how it does it. So I hope you won't get lost. If you have questions, put them in the chat or the Q&A box, and I'll try to get there as quickly as possible, or not. We'll see. So what is Playwright? Let's look at our history, and I'm going to start with recent history, more with Selenium, because that's what most people know. We have web applications, we want to automate them. And Selenium is an automation driver, basically. It's not a full test framework. And Cypress is sort of, and Playwright is too. What makes a test framework? A couple of things. First of all, it identifies test with usually by the files that have tests or specs in them. I'm talking about Playwright, of course, or the tests in the function. We'll see that as well. The other one is registration. Registration is basically if you tell whatever test framework that you use, run me only these tests in this file, for example. And obviously you can do only this test and just a bunch, the whole folder or whatever. What it does is it goes and searches for all these things that identifies as tests and then collects them, and in what we call a registry. Every test framework does that. The reason it actually runs what you asked for is the process of what we call registration. Selenium does not do that because it doesn't have any concept of tests. It does not deal with tests. You run Selenium inside another test framework. So we have test identification, test registration, obviously the execution, running the tests, and what comes with it at the end, reporting. We actually would like to know the result of the tests. And to help us with that, the fifth part, which usually comes in test framework, is asserts or expects. Way to tell the test that this is okay or this should fail. And there are other ways to do that, but usually this what comes with the test framework. And Selenium, like I said, does not do that. It comes as an automation engine that you use inside a test. And you write tests in your own test framework. Playwright, like Cypress before it, becomes a full test framework. So it gives you the entire engine of running and identification and reporting. And it comes with expects of its own. A bit of history, like I said, a few years back, Google was developing a way to automate the browser in a better way than what Selenium was doing at the time. The project was called Puppeteer. The project got stalled, and the people working on it got stolen by Microsoft. They moved to Microsoft and started working on what we know today as Playwright. Playwright's kind of new-ish, a couple of years old, but it is continuing to grow as a web testing framework. That's the history lesson. How do you work with it? Basically, you install it and that's it. That's true almost in every technology that you're using. I'm going to show you examples today in TypeScript, but you can have Playwright run as in most languages, Java, Python, C#. You have like engines for that, and most of them do what all the others do. So let's talk about how does it work. So any web test works basically with the components that you see on the screen. So you have a test framework. In our case, it will be Playwright. So when you install Playwright, you have a chance to install at the installation point or after that. Also drivers. Drivers are the ones that operate the browser. So you have a driver per browser type. I will show you today. I'm going to run through test on Chrome. So you have a driver through Chrome. If you worked with Selenium, you do this. You know this, Cypress as well. The identification, the update mechanism of the drivers is a bit smarter than what we have in Selenium. You don't have to run to chase Chrome versions like I did in Selenium. A bit smarter than that. So the test framework, you write tests in it. They run drivers. Drivers operate a browser. A browser can run HTML. So whatever you do in the browser, wherever you're going to wind up with HTML code and JavaScript, and the driver operates the browser, and the browser lets us know about the document object model that it holds, the HTML, so we can understand what it's holding, what is visible, what is disabled, what is enabled, what you can do, everything with it, identifies element in the HTML, and operate them like regular, what you think to operate as a JavaScript functions, the driver does for you. It is important to say that we're running whatever is in the browsers, and we'll see in the test, and that's, again, something that everybody who's written a web test before knows that. I want to mention, though, that the web front end obviously usually talk to a backend, and what happens in the backend is something that is going to be important to our story, because we can operate just a front end, and sometimes it's important to check what happened in the back end, because that's what the results are, and not always you'll see things happening on the screen. So what we're calling a web test usually involves operating things on the screen, but also things behind the screen. And we'll talk about how Playwright helps with that later. Other things that it does, like as I talked about the drivers, it can emulate mobile browsers as well, so you can work with it to see if things are in the port view, in the viewport, like in the screen, outside the screen, stuff like that. And basically it allows you to find things on the page and check the properties, which is what we want from a test automation framework. Anything else? Drivers, we're talking about Chrome and Chromium, sorry, so it's Chrome and Edge, and Firefox WebKit for Safari. That's basically how it works. I think we're going to jump into examples to see how it looks like. So, going to jump into Visual Studio Code. So, if this is the first time you see it, this is the first time you see my application here, which I built. It runs locally. This is a registration, like for a newsletter thing. So what you see on the screen is actually running on my machine. See, it's localhost 3000. What do we have here? So when it opens, this is how it opens up. 3 empty fields, 1 checkbox already checked, the other is not. If you click that you've read the whole term sheet and agree, it will enable the button. If you don't, it will disable it. If it's enabled and you try to register with anything which is either empty or in this case doesn't look like an email, you will get an error message here. Please make sure all fields are filled correctly. If you type something in one of them, the error message goes away. And if you go and do this, okay, let's do this, and you do the register, what happens is that first it calls an API on the server and saves the data, and then shows you thank you with the first name. That's basically it. It navigates to another page, by the way, the thank you page. Okay, so that's the application. How does a test with Playwright look for that? So you can see it here. I'm working, like I said, inside Visual Studio Code. I have an extension, what you see here, small triangles, and it's an extension for Playwright to run inside Visual Studio. I don't have to use it, but it's a lot more easy to work with. I can work from the command line completely. When you start working, before we jump into the code itself, about the setup a bit, you'll see that, where's my config file? You'll have a Playwright configuration file, which opens here. This configuration of all kinds of things. First of all, the most important, I think, is where to find the tests. Usually you work with either a spec or a tests.ts, JS, and this is how it identifies tests in them. You have all kinds of ways to work with it in terms of different configurations. I do want to mention a couple though. This is the base URL. So you'll see in a minute that I'm not writing http.localhost or 127 in every test. This is like a shortcut to tell you what the base URL is. It's very useful, especially in different configurations that you want to run against production, locally, whatever. You have the projects array, which is where you define which drivers you want to run. So whatever is open not comment or not in the comment, it will run the same tests on each driver, and you'll get the result on each driver. So today I'm going to run only on Chromium. You can see that you have like this is the emulation, mobile Chromium Safari, the branded ones, like I want to run on Chrome, not on Edge or something like that. You can do that as well. And we'll talk about the web server later. Let's go to the test. So this is the first test. I installed from npm Playwright, just downloads the drivers, asks me what to do, and then I fiddle around with the configuration to make things run the way I want to. And this is how it looks like. This is a test, as you can see. This is not a test of, if you're familiar with either Jest or Jasmine or whatever framework in JavaScript, this is a test that comes from Playwright. So, like I said, Playwright is its own test framework. And you can see that the test accepts a page, okay, which also comes from Playwright. And through the page, I do most of the operations. So this page that go to navigates, obviously, and this goes to the base URL. It's a shortcut, and it will go to the base URL that I told it to. The way that Playwright deals with HTML elements on the screen is by calling them locators, and you can find them in different ways. I'll talk about them in different in a bit more, but this one finds this text, get by text, and this one finds the promotion checkbox by looking for a checkbox with this kind of text, and this one finds the button here. And then I can write expectations on it. I expect the title to be visible. I expect the promotions to be checked, and I expect the button to be disabled. Couple of things to notice. First of all, the expect. This is part of Playwright as well. So if you worked with JS DOM, for example, for component testing in React and Angular, you'll be familiar with it to be visible, to be hidden, to be checked, stuff like that. This all comes from Playwright. It's very similar to what we have in other libraries, but Playwright comes with its own expects. The other thing to see is all the awaits here. We need to remember, let me just bring it up, that what we're doing is running two processes at least. So this is a process that runs on its own, and this is a process that runs on its own. So to synchronize two processes is very hard, basically impossible. So the idea is we're basically sending a message, an asynchronous message to the driver, who sends an asynchronous message back to the browser and tells you, go click that button. And until the driver tells us, okay, the button was clicked, or meaning the old script here clicked, things can happen. Okay, so the synchronous nature that we're thinking about this test, do this and do this and do this, doesn't really happen in reality. The way to simulate that is through async await or promises, the way you think about what's happening. What happens is that first you do this, and then you block to wait until all the things happen in the background until it finished navigating to the base URL, and then you can continue. This is the second test that runs the entire process, navigates to the base URL, finds the locators, do all kinds of operations like check the checkbox here to enable the button, fill the text boxes, click the button, and notice that when the button is clicked, it navigates to the thank you page. So by now, after this, the page will actually point to the thank you page. Right. So when I go look for something on it, it will find the thank you message, and then I can check that the text is visible. That's a lot of what it does. That's basically it. How do I run it? I can run it from the command line and npx playwright test. I can run it through the extension. Let's see. Let's run it here. So I'm running in Visual Studio Code. Inside Visual Studio Code, you see the icon has changed. This runs here. This is checking what happens when the registration opens correctly. Just this loads correctly. And you'll see that, first of all, it's exceeded. And these are the times it took for each step. And you didn't see anything. And the reason you didn't see anything is because the default mode of running tests inside Playwright is headless mode. It doesn't open the browser visually. We'll talk about that in a minute. But if I do want to do this, I can do one of these things. I can actually run it with show browser, part of the extension. So if I do this and wait a bit, you can see the timer running here of how long it takes just to get to the test. These are slower tests than regular unit tests and stuff, of course. And now you can see the browser, what's happening. It doesn't do anything here. That's okay. Because this doesn't operate anything. The other way to see what's happening, let's run the other one with a browser. I didn't do show browser. I want to debug the test, and when I run it with debug, it will also open the browser. Debugging is much slower than running it. If running is running, debugging is walking. We'll wait for it. Thank you. And then you see that it loads, it fills everything, and runs. And again, the extension lets us know how things were working in terms of how long each step took. Another thing that comes with Playwright is the trace viewer. I'm going to run the same test again with a trace viewer open. Of course, everything that you can do from the extension, you can do from the command line. So let's run the test with the test reviewer. I'm not debugging right this time. It does open a tool called the trace viewer, as you can see. And we'll wait a bit until it comes to understanding what actually needs to run. And then what you see on the screen is this is how it runs it, the different steps, how each step, how much each step took, before hooks, after hooks, if you wrote something to the log, what happens here, the timeline, the changes, a lot of the things that you need to debug happens here. So part of Playwright, and that's like Playwright sees itself not just as an execution engine. Obviously, it's a full test framework. The whole thing about developer experience is very important here. Close that. Me close that too, so it won't bother us. And yeah, remember, I told you, and I didn't lie, that this runs. So when this is running, the tests are running against the real application. But it doesn't have to, because it can, let's open the configuration again in the right place. Remember, there was a part of the configuration of Playwright with web server, and you can actually load your web server, your application, locally or not locally, even if the application is not running. It's very useful. It will run it not per test, the entire run of the test, and kill the server after that. So you can give it the command to run. In this case, I'm going to run this, the local build, the development build locally, tell it where to find it, and it will work from there. Usually, but not always, working with this might be faster than working with a remote server. However, when you work with this, development server, it's not optimized. It's not optimized to do anything. So maybe working with a built version will be faster in terms of feedback. Okay. So yeah. I told you that Playwright works with basically with HTML elements. How does it find them? Locators. So let's switch to this. So this is the documentation of Playwright. And you see that you can find by different ways. The recommended way is page.getByRole. This is like how the user sees it. So if you have a text box with a title like register, tell it go find it. Go find a button with register on it. It will find it. It will find all the things that look like that. But if you have one button, it will find it. You can fetch by get by test or by label, by placeholder for text boxes. So these things find different elements in different ways. So placeholder will not work for buttons. It doesn't have placeholder, but text boxes do. And if it finds many, it will return an array, and you can continue from there. It's like other engines as well. You can see that you can get by test ID. Like if you're familiar with the developers putting data test ID attributes on elements, it will find it by test ID. But the recommendation is to test like a user, and user will not see test IDs because it's in the code. So go by what you see, or but what the user sees first. You can also search, if you're familiar with XPath and CSS locators. Page has a locator function at which you can put whatever you put here. So if you're used to going into DevTools and finding the XPath there, it will work. The problem, of course, about XPath being really not readable, only writable, is that everything is text-based. Even when you're looking for a button with the name, it's string-based. So it's very easy to corrupt this string. So you have to be very first careful, but also try to go with usually by the roles. The other thing that comes from Playwright are the assertions. And there are two types of assertions. And the auto-retrying ones, and you already seen that. Expect something to be attached, checked, disabled, editable. We saw all these examples. And it has other aspects, like in Jest or whatever, Jasmine, whatever test framework that you use, like expect 2 and 2 to be 1. So we'll talk about this in a minute on why it's called auto-retrying. What else? Let's go back to the test for a minute. Here I'm checking that the button is to be disabled. I can also write not to be enabled. Again, very similar to what you have in React testing library, Angular test libraries, and so on. So this works as well. Do I like it? I usually don't like having too many ways to do things. It does work. Usually we're using not for binary things, true, false, hidden, visible, enable, disabled. I find it breaks a bit the conventions, so let me fix that. So I try not to use not unless you have like something that is not a negative number or something like If you're looking for something that is visually, it usually as a binary thing. If you have a list, count the numbers, go for the exact thing, not the not thing. Okay, so that's about readability. It gives you options. I gave you my recommendation. What's cool about it? So a couple of things are really interesting about the design choices in Playwright. I think we'll start with the first one, which is like having the headless mode as default. I think this is like the right choice, not because you have the confidence that things will work on the first time, which of course they do, but it shows that the feedback cycle is very important for the developers, and you already seen like bits of things that speak to the developer experience, and the developer experience should be like moving forward. So it gives you all kinds of tools to do that. I think the first one is this one. The second is the locator. So let's look at the test again. So if you are familiar with Selenium, for example, you're familiar with what we call stale elements, is you get a reference to an element like this and hold it in your hand. Then something happens to the DOM, and what you keep holding in your hands is not relevant anymore. Selenium will throw so error that's saying that this is a stale element and so on. And then you have to write some handling for it. And the way that Playwright works is with what it calls auto-waiting locators, so, or retrying. What happens is that when you go searching for the locator, it doesn't actually do that. Where does it do it? When you actually do something with the locator. So here it's checking that it's going to be visible. Here it checks, goes find this thing, where's the text, finds it, and tells you that it's visible. If you're going to click on something, same thing. If you're using the same thing, same elements 5 more times, every time you use it, either to check on its status or do something with it, it will recalculate and try to find it. Which leads us to something a bit problematic. Let's say that I write here not. So obviously this should fail the test, right? Because this is disabled from the beginning. So let's wait for it to run. And you can see it's waiting on the final one. And the error that I get, and you'll see that a lot, is that timed out, the default is 5 seconds, waiting for expect not to be disabled. So what happens is that it looked for a change in the DOM, in the document object model, and found the button and waited for it to become disabled. Okay, it didn't in this time, in the span of this timeout, and therefore it failed. So this is like everything, like I said, is asynchronous. So Playwright just gives a timeout for any operation that you do to succeed. And if you have an expect on it, it will fail. So every error here is not that it doesn't give you information. You can see that expected, not disabled, received, disabled, but it comes in the form of a timeout rather than I was expecting this, something else happened. Instead of this, I got this. Yes, but what it actually means is within my time spent, I didn't get to that status. Now, this is like a pet peeve for me because I've been chasing bad error messages all my life. professional life, and I really don't like it. It's like Playwright tells us this is how I work, and this is not like how the user or the developer works. Because the developer doesn't care about timeouts. So get used to seeing timeout messages. The information is there. You will get what actually happened. Let's fix that. Okay, let's run it. I don't like to see reds. So the whole thing about having the auto retries and timeouts and stuff like that, that makes me write very concise tests. I don't need to handle any timeouts or exceptions or stuff like that might happen. I just write this, and it's a step-by-step thing, which is makes very readable tests. Although you can already see that there's a lot of sort of a block of codes, I call them. Page is duplicated a lot. Get by role, what you're looking for is a button, and you probably want to extract that into these kind of things because it makes these things a lot more readable. So even the concise nature of the tests, you probably need to fiddle with it again. Same with the locators, like you already see in these examples that I separate finding the locators from the actual operations between them. You don't have to. You can define them whenever you find them, but I find that moving them to one place, we'll see other examples soon, makes for more readable test. You actually need to work at it. So it doesn't just come out of the machine like that. Okay, still here. Let's move a bit forward. The dynamic part, because of the way it works, the testing the error messages that appeared here, like this. So this appeared in the DOM because it wasn't there before, and when I type it here, something, it disappears from the DOM. This is why you don't see it. It's not there. So how do the tests look? Well, they look the same. Oh. Yeah. So because of the way things work and locators are calculated when they're needed to, so this here, here, the error message, I can put the error message in the beginning of my test because it doesn't do anything, and it will be calculated here. And after I click something in the text box, I can check it here to be hidden because it's going to be recalculated again. So this auto retrying, timeout based, whatever you want to call it, makes for very concise reading. Note that Playwright deals with elements. So if you try to say, well, why am I checking the terms checkbox here? Because this is the only way I will know that the button is enabled. Playwright doesn't know anything about what's happening here, the connection between elements, and what is the result of the check that it actually enables there. You have to convey this thing or express in different ways. One of them is comments, like you see here. Others is more refactoring, more better naming, but Playwright doesn't help you with that. You have to work at it too. Okay. So that was the dynamics. Let's talk about isolation. So by default, Playwright runs each test in isolation. What does it mean? It runs in its own browser, in its own page. So when you see a page, it actually runs in a browser. It actually is a browser context, and it creates completely separate page and memory space from other pages that may or may not look like it. That's true, but it becomes a bit more complex when you think about, well, what is it actually running? yes, it runs different pages in the front end, but all of them go to the same backend. And the default of Playwright is to run 4 worker threads, so 4 tests in parallel. Things can get very confusing for us and for the tests when they're running in parallel. So you have to tweak that to see how brittle the backend is to actually run more tests in parallel. I want to show you. So this is a way to run the same page in same page, like 2 pages of the same registered page in the same browser window. So you see that it doesn't get past the page, but the browser context. So this will open one browser and open 2 pages of the first page. So let's going to show you that. While I do this, I'll tell you that the other one, which gets a browser, does the same thing with opening a new browser window. So you can do that as well. We're still waiting till it loads. We're getting there, I think. Browser, and then another page, another tab in the browser. Note that when I'm running with show browser, it doesn't close the browser. This one will create, because I'm working with a browser, not a browser context, it will create, it will run 2 browser windows. Each one will open its own page. So you have like, we can play with that. Isolation remains isolated as long as the backend is isolated, which it usually not. So you have to tackle that in again. This is the first browser window. This is the second browser window. Opens 2. By the way, part of the isolation is running in incognito mode. So it doesn't have any history, it doesn't have any cookies. Isolated is isolated. Again, I like the focus on stability of tests, because otherwise things will happen. Okay. Bit about isolation. Playwright sees itself like more than just a test framework. It has other tools. We already saw the trace viewer, which is a debugging tool. Every testing tool that you get today will come with a code generation. I'm going to show you how it works, and we'll talk about that. So let's do this. I'm going to run it from the command line. You can do it also from record new, but I'll do it from here. So npx playwright codegen, and what it does is open 2 windows. The first one is the Playwright inspector, and the other is a browser window. And you already see that it's recording, and whatever I do here will be here. Let's see how good it is. So I'm going to go to my application, and you can see that line page go to is here, it's created. Whatever context I'm doing here, it kind of catches. So let's do this to check the terms, and then let's type something here. Notice that I clicked on the text box, so it recorded a click. It's usually what I don't want in my test, but we'll talk about that in a minute. Let's write Gil here, and let's give a few things here: assert visibility, assert text, and assert value. Let's say that the value here is Gil. created and expect. Let's look at what we got. Okay, so this is a health test, yeah. And actually, I can save that and use it. But a couple of things that are annoying. First of all, it recorded exactly where I was going, but I'm using the shortcut for the base URL. So I'm going to change that. It found the checkbox, the terms checkbox, but by using the get by text rather than what I did was get by role, find the checkbox. And notice that it found the text boxes, get by placeholder. And it repeats that. So every time I touched this locator, it wrote page get by placeholder, both here and here and here. What does it mean? It means that it works, it generates the code the way that it likes, the way it finds things. You can work with it a bit to tell it how to do it, but first of all, it creates a lot of duplication. You see the page get by placeholder. Also, it doesn't work by its own rules, which says go by what the user sees, and what the user sees is you get by role, but it doesn't do that because it's not smart enough today, at least. So what can I tell you about CodeGen? Yes, it works. You can work with it, but if you actually want not just to generate tests, but you actually want to have tests that work with you for a long time, either write them themselves, or what I did is like you either do some prototyping with it and find some very hard to pin locators. It can help you do that, but it might not give you the locator that you want and not the code that you want. So be aware. Close that. So that was CodeGen. Yeah. APIs. So like I said, Playwright sees itself not just like a web automation thing, but like a testing thing. If you want to test, you probably need to reach the backend somehow, or whatever backend. So it gives you a way to call APIs. Let's look at example. Yeah. So you see that we have a request object from Playwright again. So this test goes through the entire registration process. So all this you already saw, what's happening on the screen. But then if I want to check what actually happened in the database, I have an API called all, which brings everything in the database. The way it works is as a local database, JSON database, and it brings everything. And what I do here is basically call the API, get the JSON out of it, and then compare that the last entry in the thing is exactly what was filled here. And so this support of APIs is very important, because this is how you can set up things, clean up things, check things that happen in the backend, like this thing. So having this thing out of the box is very helpful. Otherwise, you will need to do other stuff. Go to fetch or access or whatever. Get everything out of the box here. Accessibility, it even lets you do accessibility testing, not by itself, but by integration with the X library. So you could see, oh, damn it. So while it's running and debugging stuff, you'll see that the test is in skip. First of all, it imports the X builder library, which does accessibility testing. And basically what it does is you tell it, well, go to the page and analyze it and tell me what you get. Let's remove the skip, now that you know how to skip tests, and run it again. This time without the debug. And what will happen is this will fail. I left it open. Yeah. Why are you running this thing? Okay. Close this. And you see that I expected 0 violations. I actually got 2. If I want to see what they are, let me run this again to get to the other exceptions. And this is where you get an array of the violations of accessibility that the library gives. When I first ran it, I was pretty sure what will find. I didn't know it will find one of them, but you can see that it's about the contrast, and the grays here are like that contrast. So if you are worried about accessibility, and you should be, this is a very nice way to make sure or to find accessibility violations very quickly integrated with Playwright out of the box. So also documented. So okay, what else? Coming up on the hour that I grouping. So up until now, I showed you how to run tests in basically either select the test I want through the extension, or in the hierarchy level where it finds different module and the tests in them, or I can do whatever I want in the command line. Basically, whatever the extension does is create the right command line to run the right tests. So everything's possible. But if you're familiar with any test framework, you're probably looking for, well, I need a common setup. I need to put things together. Well, how can I do this? So do I have something like a describe? Yes, you do. It just look a bit different than what you know. So let's look at that. So it's called the test.describe, which is basically your test suite, and you have a test before each and before all and after each and after all if you need to. Notice that you can, if you're used to putting things in the before each, good for you. It's for common setup, and that adds a lot to the readability of the test because it removes the common stuff. When one of them fails, one of them passes, it's much more easier to see what is the difference between them. And obviously you can put the locators here because they're not really doing anything here because they're going to be recalculated whenever the tests actually run. So this, again, part of the box that comes out of the box. I want to talk about fixtures. Now, if you know test frameworks, you know fixtures. The before each, before all things are part of what we call for 20 years, 30 years now, fixtures. Fixtures are basically a weird word to say these tests have a common setup and a common cleanup. And I want to remove everything common from that to different position, before each, before all, and so on, and just have the test have just what it needs to do. So it's about code organization. Playwright took this idea a bit forward. So I'm going to talk about that. I'm going to start with an example of how to write what we did until now with a page object model. And the reason is that fixture and the documentation about the fixtures in Playwright talk about a page object model as an example, which is always a good idea most of the time. So let's look how would our page object will look for the registration. So where am I? I'm in the test explorer. This is what let's look at it. Yeah. So the page object for registration, my registration page looks like this. It got all the text that I need to do, all the locators that I need to find. It creates an abstraction from the test. I have an initialize method that does things and goes to the navigation, navigates to the page, and has all kinds of method like type in last name, type in first name, type email, blah, 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 blah. So, and verifies things, verify them boxes unchecked, verify promotion boxes checked, all the things that wrap this page in terms of operation and checking. What is also interesting is when it does the navigation, it returns another page object, the one for the thank you page. How does a test for this look like? So far we haven't touched fixtures, just using a page object. You can see that it's a lot nicer. So it doesn't have It uses my words, initialize, check term box, type in first name, type email, and so on. Note that I'm using initialize, and the reason is in TypeScript, a constructor is not asynchronic. So if I want to do the navigation to something await in it, it cannot be done in the constructor, so I have to separate that. Okay, so that's cool. What does a fixture look like? So a fixture will take the page object model and wrap it in something called base.extend, and you can put in the common setup that you want. For example, initialize is what I want before every test. But also, if I want some behavior, I can put it here as well. So for example, if I want all my tests using this fixture to start after I check the term box, enabling the button, I can do that. And this line here actually runs all the tests. Use the page and actually does the tests for you. So it's a decorator pattern. If you know some design patterns, this is part of that. And you can put like common setup, common cleanup. And what's so cool about that is before each and before all and their brothers and sisters work very well, but for all the tests inside one module or one file. If you want to use a setup, a common setup or reusable setup for multiple files, most of the time you don't have that. If you know Java and TestNG, it does have that. You have something like before suite and after suite, but most frameworks don't have that. And Playwright has decided that it is possible to have different way to get to a point where you want to start tests that can be reusable over files. So you have this very nice feature that helps in maintainability and also in readability, because it moves away common stuff to other files, which then if you look at what's left of the test is this. You pass in the fixture and then you have whatever is left here. And again, more concise tests are better and are readable and a lot more maintainable and also more debuggable, because like I said, you have a couple of tests using the same fixture. The shorter ones we understand better, and understanding what is okay with this one, what went wrong with that one. So coming up on our hour, what's the verdict about this? So Playwright's very cool. It's new if you compare it to other frameworks, but it has all the things that you actually need, not just to generate tests and write tests, but live with your tests, debug them, maintain them. It pushes you toward better practices in terms of how to manage your test up to a point. It's still on you to create more readable tests than what it does. Use the features in order to make them more readable and maintainable, things that we talked about. And the code gen thing is helpful, but don't rely on it, especially in the way that we usually work, which is like have a test working, then copy that and like mutate it a bit. And if you copy crappy code, this is what you get, a lot of crappy code. I really invite you to download and try to use it if you're not using it already. Read the documentation, it's very good and very nice example. It's very easy to get into this in terms of write your first test. And final thing I want to say is that if you dabble with TDD, test-driven development, I try to work with it in this way, like test first, right? Not generate, of course, but I created some kind of both rhythm and workflow that helped me create test first. This is a whole session probably that I'm going to do somewhere in the future, but you can actually work with that. And this is like, I don't think that I found something that can help me work with that before in web. And that's what I wanted to share with you today. So reminder, there are courses also on Playwright, but other courses as well on the site. If you go to testingguild.com or everydayunitesting.com, which is the same site, you'll find all about my courses and workshops and services. If you have any other questions that you might think of, put them in the question box or the chat. Question: in Playwright, do you start the test with recording or should code everything manually? That's a very big question. Okay. The idea is you start recording or you start working on something that works. If it's working, you can go to the code gen and generate this and then change it to what you actually want. I found that there's a lot of changes for what I wanted, and that's not a very big application, obviously. So I kind of gravitate towards writing by myself once I know where to find things. The code generator helps me find things. You have like the peak locator stuff and expecting, especially for dynamic things that may not be that easy to find, let's say, or things in a list that you want to see how do you get to the fourth one. So it helps you, it nudges in the right direction. The bigger the workflow, I would recommend like starting with the generating the recording stuff, see that it works repeatedly, and then look at the test and either rewrite it or change a lot, refactor it a bit. Even the fact that it creates the, I showed that in the codegen, that it duplicates the get by placeholder all the time. You don't want all this duplication. You have to, you probably want to create a locator somewhere and create better code in there. So use the code generator to first give you enough confidence that things are working, and use it for give you like a framework or a skeleton of what you actually want to do. Don't leave it as you got it from the code generator. It won't serve you like that forever, like you want to. I hope that answers the question. I'm going to thank you for coming today, and I hope to see you in the next webinars. Other than that, watch the site for content, watch YouTube for content, and follow me on social media to know when these things will be up. And see you next time. Bye-bye.